Howdy Calc PC, welcome back to another video. We are leaving the world of limits and we are headed straight into derivative town. And I think you'll remember a lot of this stuff, especially this first video, because it's really just a review of some of the more basic differentiation rules along with the limit definition of derivative. Next video up for Thursday, we'll have more for you on product rule, quotient rule, and chain rule. And then we'll continue on learning how to take different derivatives before we come back and circle through for applications of derivatives. So a little different sequencing than maybe you experienced in your Calc AB class, but that's because we're just mostly reviewing rules for derivatives right now. So let's go over to the whiteboard and take a look at a couple things. And this video, I think, will be much shorter than ones that I've done previously for you. I'm going to start off with the limit definition of derivative because it is important to remember that the derivative really is just the limit of the slope equation. So when we had we kind of developed this idea last year, so I'm not going to go through too much of it. Just a reminder that you know, x plus delta x is just a different x coordinate. And when you take the function value of it, that's basically y2. And f of x is basically y1. So this is y2 minus y1. And delta x on the bottom is just x2 minus x1. So, you know, like I said, it's just a slope equation. The difference is now the 2 points that we use to find the slope are going to get closer and closer together. In fact, we get so close together, the distance between them becomes 0. And we call that f prime of x, the derivative of the function at the end. I want to stress that the limit has to exist. If the limit exists, you know, f prime of x is important that it exists. So it's differentiable at that point, then it's also continuous at that point, and that differentiability implies continuity idea is still a big deal. It's not going away, so please remember that if they say it's differentiable, that it also means it's continuous. There's no way for this limit to work out if the function, somehow this limit would exist, yet the function itself would be discontinuous, wouldn't work. And you can see that with the f of x plus delta x. If you were on some sort of a vertical asymptote, you know, one of those would be infinity. So yeah, it is a really great way to prove continuity if you can prove differentiability. So there it is, you know, and I think you know, there's lots of examples in your textbook of how we use the limit definition to find a derivative of a function. But of course, you know, as you probably picked up last year, you know, Newton was no slouch, and he figured out pretty quickly that there are certain things that happened every single time. And so these are the basic derivative rules that we want to run through today. And then once we get the basics out of the way, we'll get into some of the more complicated rules on our video for Thursday. So let's start with some of the real basic ones. The derivative with respect to x of a constant. Yay. We already know that that's going to be 0. So these are just quick reminders. The derivative with respect to x of a constant times your function, right? That's just the constant times the derivative of your function, right? You can move that constant outside of the derivative, right? That's because you can move a constant outside of a limit, sure. We had the sum and difference rules, the derivative with respect to x. Now we have two functions, right? We got f of x plus or minus g of x. Okay, yeah, and that's just f prime of x plus or minus g prime of x. I'm going through these kind of fast, guys. I know you're smart kids. You already learned this stuff. You already know this stuff, and so I'm not gonna belabor this too much. But I just wanted to make sure we had a nice review of our basic differentiation rules. The power rule was our first big rule. We finally learned how to derive something, and it came out of the power rule. It came out of the limit. So and so I think it's important to remember that if you have f of x is just x to some power, if f of x is x to the nth power, then the power rule is really just taking the limit definition of a derivative and going through that whole process with our function x to the n. Now, how does that work, right? Well, hopefully somewhere along the way, you learned how to expand a binomial. So that if I were to take the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x, and I know that my function is x to the n, then what I'm really saying is the limit as delta x approaches 0 of x plus delta x to the nth power minus x to the nth power over delta x. And this is where you need to know how to expand the binomial x plus delta x. I don't want to take a whole lot of time here to explain to you how to expand the binomial x to the n. It's actually in your book, the very back cover of your textbook. If you look on the very back page, there's a binomial theorem. It's on the same. It's opposite from where all those trig things are, and anyway, it gives you the formula for how to expand this binomial. So I'm just going to use that formula, and I won't write out the whole thing. I'll just write out a few terms of it because I think you'll see pretty quickly what happens. It's got x plus y to the nth power in there, but it doesn't really matter if it's x plus delta x, same thing. But what happens is this, guys. You get a bunch of terms that end up looking like this. X to the n, oh, oops, that was supposed to be minus 1. This is n minus 2 delta x squared, so on and so forth. Okay, that's our expansion. I'm only going to write out the first few terms because those are the only ones that are important. Everything else, delta x, you can see starts out at delta x to the 0 power, then it goes delta x to the first, delta x squared, cubed, blah, 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 blah. So the last term is going to be delta x. I should write that last term on there. Is going to be delta x to the nth power. Okay, so delta x to the n. Okay, minus x to the nth power. And boom, this is all over delta x. And what do you notice happens? Well, you probably see that there's an x to the n here and an x to the n that's negative here. So they cancel each other out. And now every single term in this numerator that's left has at least one delta x in it, right? I mean, I said it goes delta x to the first, delta x squared, delta x cubed, delta to the fourth, all the way up to delta x to the n. So this delta x is going to cancel one of these all the way down, including this guy right here. So now I'm going to go switch back to my blue here. What happens is we get the limit as delta x approaches 0. Well, I have n times x to the n minus 1 plus a bunch of terms that have a delta x in them. I started to say delta x and write it at the same time, sorry. This is n times n minus 1 times n minus 2 over 6 x to the n minus 3 delta x squared, so on and so forth. Well, as delta x goes to 0, right? All these terms with delta x, this is gone, this is 0, this is 0. They'll all be 0. The only one we're left with is this guy here, and it doesn't have a delta x in it. So we get n times x to the n minus 1 power, and that's your power rule. It's exactly the one that you knew we were going to get, right? If f of x is x to the n, f prime of x is n times x to the n minus 1, which is exactly what we got here using our limit definition. So no big surprise there. We already knew that one. So that's really the main bulk of the review that we're working on here today. The big application, of course, to start off the year or start off the derivative section was tangent lines. So, the application, I guess, that you might see in here, tangent lines. And I'm not going to go through a tangent line problem with you. I just want to remind you about point slope form. It's really handy for these problems with tangent lines, because now we know, point slope form, you just do y minus y1 equals m times x minus x1, right? Where x1, y1 is a point on the line and m is the slope. So for us, we'll just write it like this. We'll say, for calculus kids, we'd say y minus y1 equals f prime of c times x minus x1, right? Which is f prime of c is the point where we found the slope. So, and so that's a nice, easy way to think of tangent lines. So there you go. Derivative means rate of change, means all that same stuff as before. I'm not going to hammer that too hard. We'll see plenty more of that as we go through. So there's your quick review. I know it's probably one of the shortest videos we'll make all year, but there it is. The review of the limit definition of derivative, basic, very basic differentiation rules for polynomials. And that'll be it for this first video. So I would imagine we won't have a lot of questions in class, and we'll get you right to the homework, and it shouldn't take too long. So, all right, guys, thanks for watching. Have a great day. I'll see you in class.